Hello learner, welcome to Manifested e-classes. We are going to continue working solutions to questions on our topic measurement 1. So in the previous lesson, I'd given an assignment which we are going to tackle on the board. So let's listen to what the questions said. And because of board management, I don't want to wrap the question before we go through it. So we shall start with question 3. Question 3. It reads, Lana, the following data was recorded in an experiment to determine the density of a liquid X. So just of a liquid X. So density of a liquid will still be correct. The density of a liquid. So it separates from water. So 1, mass of the empty bottle was 30 grams. Mass of the bottle filled with water. The bottle is now filled with water. It is empty, but now when filled with water, it is 55 grams. Number 3, the mass of the bottle filled with liquid X is 370 grams. Before we get to getting the solution to the question, there is a concept in physics that is being built there. The concept of relative density, whereby the relative density of a substance is the density of that substance divided by the density of water. And before you make any further move, the density of water, always known, density of water. Density of water is always taken as is 1 gram per cubic centimeter. This should always stick to your head. Or when you convert to kilograms per meters cubed, it is 1,000 kilograms per meter cubed. So when you go to air, you now get to the formula now. Density is equal to mass. Calculate the density of water. So here I had already given it, but now we are going to see how we shall get it. Mass over volume. Mass over volume. So we go to the data. Mass of empty bottle, 30 grams. Mass of bottle filled with water. Isn't it? So density of water. To be clear there, density of water will be the mass of the water. Will be 55 grams, subtract 30 grams, divided by the volume. So for volume there, let's see what happens. Isn't it? From this one, we know we shall get 25 grams. So volume, as we know, will be mass over density. And as always known, the density of water is 1 gram per centimeter cubed. So the volume of water will be given by, if we work out this, we shall get 25 grams divided by 1 gram per centimeter cubed. So the gram will cancel with the gram. So when this goes up, it becomes positive. So it's 25 centimeters cubed. So always know, in most of the questions you are going to work out, the density of water will always be taken to be 1 gram per centimeter cubed. This, we shall now be relating the densities of other substances to that one of water. That's why I started by saying relative density. If you find a substance to have 8 grams per centimeters cubed, its relative density will be 8. Because 8 divided by 1 will give you 8. So this will be over 25 cubic centimeters. So you'll come and have 25 grams of the water we got there, divide by 25 centimeters cubed. So our answer, 25 cancels. We get 1 gram per centimeter cubed. So in the question they are not given the density of water, but they expect you to note the density of water. Water is universal. In fact, man interacts with water always. So the density is always given as 1 gram per centimeter cube. Let's go to B. Density of liquid X. Now there is something that has happened there. It is the same volume, that's why I talked of relative density, whereby you learn that the mass of substance over mass of an equal volume of water gives us relative density. It is the same bottle. The capacity has not changed. The volume has not changed. So you'll come and you'll have 370. When it is filled with liquid X, the mass is 370 grams. When empty, isn't it? So just to make it clear there, I have to say mass over volume. So I'll come and write 370 grams, subtract 30 grams over. So I said the volume of that bottle did not change. So it will just remain to be 25 cubic centimeters I got in the first question. Divide by 25 cubic centimeters. So if I work out that, I'll get 340 grams divide by 25 cubic centimeters. This gives me 13.6 grams per centimeters cubed. That will be the density of that substance. Later on, you'll find that substance to be common in your calculations, maybe when you come to pressure. That is mercury. So let's go to question number, we can go to question number 1. Let's go to question number 1. So here, in an experiment session, the B rate reading is 18.1 cubic centimeters. You'll meet that in chemistry when we are doing the experiment. The B rate reading is 18.1. After the teacher's demonstration, each student was supposed to release 10 drops, 1, 2, 3, up to 10 to the B rate. Each of those drops is given as 0.3. What is the reading of the B rate after the third student? So it goes straight. Final reading will be equal to the initial reading, the first reading, initial reading, plus total number of drops, total volume of drops. That is what you should know. Total volume of drops. So you are told each student releases 10. 10. If there are 3, it is 10, 10, 10. So it will be 10 times 3. So you shall come to and have the initial reading is 18.3 cubic centimeters plus total number of drops. The students are 3. Each releases 10 drops, and each drop is 0.3 cubic centimeters. So here you'll come and have 30 times 0.3. 30 times 0.3, you'll get 9 cubic centimeters. So you'll have 18.3 plus cubic centimeters plus 9 cubic centimeters. Your answer will give you 27.3 cubic centimeters. Just alerting you of what you'll be doing in your chemistry sessions. So that will be the final reading. We now go to question number 2. Question number 2. Having finished question number 3, we at least now have some space here for the solution. Question number 3. So in question number 3, learner, you are told the table below shows densities of common substances found in the laboratory. Substance 1 is aluminium. They are saying the table shows its density is 2,700 kilograms per meter cubed. Gold, I don't know if we have it in most of your laboratories, is 19,300 kilograms per meter, and copper 8,930. A substance of mass 7.144 kilograms was found to have a volume of 800 cubic centimeters. Use the information to determine the substance. You'll use that table. So you'll come straight to your solution. Density, you'll actually use which parameter? You'll use density. So you'll say density is mass over volume. Luckily enough, the mass is given there, 7.144 kilograms. You'll divide by the volume. Volume is given here. Volume is given there. You have to be very careful there now. So you are given 800 centimeters cubed. You have to be very careful there in conversions. 1 meter cubed is equal to 1 million cubic centimeters. Cubic centimeters. So 800 centimeters cubed has to be equal to 800 divided by 1 million. You convert to meters cubed. Meters cubed, the 3 zeros. So this will be 0.008. 0.008. You convert this to meters cubed. You can't work with kilograms and centimeters cubed. So this will be 7.144 kilograms divided by 0.008 meters cubed. Giving you, work out that well, it will give you 8,930 kilograms per meters cubed. So from that you already know what it is. That substance is copper. The substance is copper from the table. The substance is copper. So having worked out that, it will be time again to give you an assignment for the next lesson. So those are the three questions. So the first question, when we always prepare tea. When preparing tea, water is mixed with milk. 500 cubic centimeters of milk is mixed with 618 grams of milk. Calculate the density of the tea, given that the density of water and milk is 1 grams per cubic centimeter. So this is, we have to calculate the density of the tea. So this is just a repetition, so you can ignore this. It has already been asked. Calculate the density of the tea, because we know it's already a mixture. The second question, a stopwatch was used by students to track the time in a bread eating competition. The display on the stopwatch was 01:24:90. Express the time in seconds. And the last one, a defective watch started after the button was pressed. The time indicated that the stopwatch was 2.53. What is the correct time if the stopwatch took 0.3 seconds to stop after the stop button was pressed? So those will be the three questions for the assignment before we meet in the next lesson. Thank you very much for your audience, and let's meet in the next lesson. Have a good time.